Good afternoon. This is Rich Nass with Open Systems Media, and I'm here for this week's installment of 5 Minutes With. This week, I will be speaking with Amnon Shenfeld, who is the co-founder and CEO of 3DSignals. Good morning, or I should say good afternoon in your case, Amnon.
Good day, Rich. How are you today?
I'm doing just great, thank you. So 3DSignals is into a technology that I'm afraid you're going to have to explain to me. You guys do sound-based predictive maintenance for industrial and manufacturing equipment. Okay, what the heck is sound-based predictive maintenance? What does that mean?
Well, we usually say sounds good, so I think you sort of hit the nail on the head there. It's exactly what you just described. We use airborne ultrasonic microphones to listen to machines and understand through the way that they sound their health, or whether they're being operated efficiently or not. So I guess that you could say that sound-based predictive maintenance is using the sound which is coming out of machines to understand their condition.
Would that be some sort of DSP technology where you take a baseline when the machine is operating correctly, and then when it doesn't sound like that, then you know you have a problem?
Interestingly enough, DSPs have been around for several decades now, and a lot of the classic monitoring technologies you have out there, like temperature monitoring, vibration, whatnot, are based indeed on taking the signal, the physical signal, and then figuring out through some DSP functions whether it's doing well or not, and specifically basing this decision on some pre-recording of a baseline from the equipment which is being monitored. Now, we're in a totally different technology space. We're actually an AI, artificial intelligence, machine learning, and today the right word would be deep learning technology-based company, which means we're not using pre-recorded baselines to figure out what is the condition of the machine, or rather to figure out that you have some recording which is defined as well and you're looking for any anomaly out of that baseline. But we're actually teaching neural networks which emulate the process which is going on in the head of technicians or humans to identify and learn, as the system is listening over time to a machine, what is considered normal, and be very adaptive about it, because machines tend to be very dynamic, and figure out if something is starting to go wrong, much the same way an experienced technician, as he gains experience working around machines, would figure out, hey, this doesn't sound right, and after the first time something like that happened and he figures out what it is, which in our case we tell our algorithms what the incident was. The next time they hear something similar, they don't just go, there's an anomaly or something is out of the baseline, but they would go, we heard this before. This actually means your bearing is cracked or your shaft is misaligned or you need some lubrication and so on. And that's artificial intelligence for you in the plant.
So what is the accuracy of this? I mean, it's hard for me to tell if it's extremely accurate or if it's just something that gives you a rough estimation where you know when you should be getting more information.
This is highly accurate because the algorithms that we've developed and patented are based on some of the physical modeling that repeats itself from between different machines. For example, bearings or pumps or turbines or motors and so on all have some components which are similar, and our algorithms understand the similarities between different machines much the same way a trained technician would say, well, I've seen let's say a turbine by that company, and now I'm standing next to one from a different company, and if it does a certain acoustic signal, then I have already some experience and knowledge to understand what's going on this new one, even though it's not exactly the same equipment. And to give you some perspective, I think this is very similar to the revolution we've seen with computer vision. Today, I don't know, you've probably read about it, computer vision algorithms identify faces better than human vision actually performs, and this is famously so that in security applications, facial recognition based on these AI algorithms is outperforming humans. We're doing the same thing with hearing. So we're aiming that our algorithms will eventually outperform the capabilities of human technicians to understand what is going on with machines, and the human capability in that regard is as strong as the human capability to identify faces. And another thing that is that in our case, our sensors are ultrasonic, so they're actually 5 times as sensitive as the human ear, and therefore our neural networks also have the capacity to be at least 5 times better than the most sensitive, well-educated, and experienced technician.
Okay.
Rich?
Yes.
I sort of lost you there. Hello?
Did you hear that last question, Amnon?
Sorry, I missed it completely. You just blanked out on me?
Sorry. Maybe. My question was, I was wondering why I haven't heard of this technology before. Are there other people who are doing this and I just haven't heard of it, or are you guys the first ones to do this, and if so, why?
Artificial intelligence and commercial applications around artificial intelligence have been really revolutionizing computer vision in the last decade. I mentioned computer vision being used for security applications and facial recognition, of course, and in the ed tech space. They're being used on our behaviors online to recommend better products and so on. They're getting better and better. We're in the cutting edge of applying these technologies on physical signals in the industrial space. And we're happy to do it because there are tools which are like stethoscopes existing for the last 20 to 30 years for allowing people to walk around plants and acoustically sample equipment using these handheld stethoscopes. And they put this piece of equipment in their ears. They have the earpiece, and they aim the sampling end at the equipment, and their brain is making the decision whether the equipment is behaving well or not based on the acoustic sample. So we know that for several decades, and probably for several centuries, ever since the first industrial revolution, people have been understanding machines through the way that they sound. We are among the first to apply machine learning and artificial intelligence on this highly valuable signal, which is not being used in any automated fashion. Imagine you could have an expert engineer standing next to each machine or each critical point in your manufacturing process, listening to it 24/7, and giving you an urgent phone call whenever he hears something which is out of the ordinary. And that's where we're aiming at, making it a much more robust solution than trusting a few trained technicians walking around with specialty equipment.
Interesting. I find that fascinating, and I know I will be looking for more information about this, and I'm sure our readers will as well. Well, thank you, Amnon. That was Amnon Shenfeld. He's the co-founder and CEO of 3DSignals, and I hope you have a great day, Amnon.
Thanks very much. You as well. It was a pleasure.
Okay. Bye-bye.
Bye-bye.